15.4 is segments and circles, and you are going to see segments that are staying inside the circle versus outside of the circle. And just a quick reminder, a chord goes from one end of the circle to the other. This is an example of what a chord looks like. And a tangent versus a secant, let's look at secant first. A secant is going to be a line that's going to cut the circle into two or more pieces. So we have one piece up here, one piece right here. That's a secant. And remember, a tangent, what a tangent is, it's also outside the circle. But that, I'll do it on this one, is where you form a right angle with the radius of the circle. So that one's the tangent. We're going to be using all those ideas today. All right, the first one's probably the easiest. It's chord product theorem, and it says this. If you have two chords that are crossing each other, it says the segment of one, so BE, times the segment of the other, so AE, that's right here, is going to be equal to CE times ED. So part of the segment here times part of the segment here is equal to this part of the segment here times that part of the segment here. So make sure you got this written down in your notes. This is important to know. Once you know it, it's pretty easy. You can see right here I have two segments that are crossing each other. So if I take a look at this first segment, this part right here, x times this part right here, 8, is going to be equal to this part right here, 4, times this part right here. And you can see what x is going to be equal to is 3. So it's pretty easy to use. Similar type problem right here. You have to pay attention to this. It says AD is 12. If AD is 12, that's this whole segment. Well, clearly that has to be 10. So you can do the same thing. 2 times 10 is equal to 13 times x. And you could then solve for the x. You get a fraction this time. That's okay. X is equal to 20 over 13. So there's a couple examples of using the chord theorem. All right, the next one is secant product theorem. And you have two secant segments here. You can see the red secant segment. It cuts the circle into two parts. And you have the blue one as well right here. And what the secant product theorem says is it says it's the whole segment, so the whole segment right here, CE, and times the outside segment, DE. That is going to be equal to the whole segment on the other side, so AE, times the outside segment here, BE. So whole times out is equal to whole times out. Again, make sure that's in your note. Here's an example of it. You have two secants right here. So you're going to do the whole thing. So the whole thing is 6 plus the x, 6 plus x, times just the outside. The whole times the out is equal to the other whole times the out. So the whole right here is 17, and the outside is 9. And then in doing this, you get 36 plus 6x is equal to 153. And you can continue on with this. And we got 6x equals 117 dividing by 6. So our answer will be a fraction for this, but I can reduce that. They're both divisible by 3. So it looks like I'm going to get 39 over 2 for my final answer of x. Let's do one more example here. We have two secant segments. So we have the whole thing, which is going to be this plus this. So x minus 4 plus 3. The whole thing times the outside, so that's a 3, is equal to the whole thing here. So this plus this times just the outside, which is a 4. When I combine what I have here, I have x minus 1. I'll have to distribute the 3. Here I have x minus 3. I'll have to distribute the 4. So I have 3x minus 3 is equal to 4x minus 12. And if I solve this for both, or for the x, what I'm going to get is I'm going to get 9 is equal to x. And it's just asking me to find x. If it would have asked me to find each of these values, of course, I'd simply plug that in. All right, the third and final one for today is called the secant tangent product. So secant, here's our secant right here. It starts out the same way. You're going to do the whole thing times just the outside. So the whole thing, AC, times just the outside here. And when you have a tangent, remember that just means it creates a right angle right here with the radius of the circle. What it is it's essentially just taking this segment here and squaring it. So just another rule to remember. Again, it's easy to use. It's just a matter of remembering it. All right, one quick example here. If I was asked to use the secant tangent, here is my secant. So I need the whole thing. So this plus this, 3 plus x, times just the outside, which is 3. And that is equal to this tangent right here being squared, and 6 squared is 36. So what I'm going to get is 9 plus 3x is equal to 36, or 3x is equal to 27, or simply x is equal to 9. And you can double check that by plugging that back in. All right, that's it for 15.4. So there were the 3 rules that you must know. You should write them on your note card so you have them for your quiz on Friday. But remember, you are not going to have them on your test, so make sure you start learning them and starting to memorize them. Have a good day. Bye.